So this is an assignment related to topic bonding structures and shapes of the molecules. The first question, which of these has the greatest electrical conductivity? So when you check this type of because the electrical conductivity depends on the type of the bonding. In SF6, it will be a covalent bond. So it does not have any delocalized electrons. It cannot be A. Water, it will have a covalent bond and there is no delocalized electron, so it cannot be B. Mercury, mercury is a metal, so it will have a metallic bond, and metallic bond, it's a positive ion and the delocalized electron, so that's why C will be the right answer. And for sodium oxide solid, so the bond will be ionic, but ionic compound does not conduct electricity in a solid state. They can conduct in molten or aqueous state. That's why C is the right answer for question 1. Is it clear? Moving on to the next question. Which of these ions has the greatest ionic radius? So how we can work out the greatest ionic radius? We should check the number of electrons and number of protons. So nitrogen, it is having 7 protons, and with the charge 3 minus, it means it will have 10 electrons. Fluorine, atomic number, it will have 9 protons and minus 10, so it means 10 electrons. So they are isoelectronic. 11 protons are there and 10 electrons, and Aluminium will have 13 protons. By using a periodic table, we can work out number of protons. And there's a charge plus 3, so it lost 3 electrons, so it will be 10 electrons. So they're asking which is having the greatest ionic radii. Here 7 protons are attracting 10 electrons. So weak force is there between the proton and electron. That is why the nitride ion will have the highest ionic radius. And which will have the smallest ionic radius. You can see 13 protons are pulling the 10 electron, so this will be the smallest ionic radii, and this will be the largest or greatest ionic radii. In question 3, which of these ions has the greatest polarizing power? So polarization or distortion is the tendency of a positive ion to shift the electron density towards the cell, that is simply known as distortion or polarization. And polarization depends on size of the positive ion and to have a large distortion or polarization, so greatest distortion will be there when size is smaller, and charge of the positive ion the greatest distortion when charge is big. So these are the two things which will cause the distortion to the negative ion or polarization. So A and B cannot be an answer. Why? Because these are negative charge. Negative charge polarization, they are not able to polarize as they are negative, they repel the electron. So either potassium can be answer or calcium. So when we check potassium, it's have ion, it is having 19 protons are attracting 18 electrons. And here 20 protons are attracting 18 electrons. So 20 proton will apply greater force, so the size will be small for calcium ion. And when we check the charge is greater, so that's why calcium will have the greatest polarizing power in this. Is it clear? Question 3. Moving on to the next question. Which of these does not have a structure formed by a giant lattice? So in a giant lattice, we have infinite number of atoms. So fullerene 60, C60 fullerene, it means there are 60 carbon atoms. So this is a finite, so it means we have finite number of atoms. This diamond, we have infinite number of atoms, and graphite also infinite, graphene, graphite infinite. So the question is, which of these does not have a structure formed by a giant lattice? So finite will not form a giant lattice. That's why fullerene A is the right answer. But diamond, graphite, graphene, they all have a giant macromolecular structure. In question 5, which of these molecule is the most polar? So electronegativity, fluorine is the most electronegative element when we check the electronegativity, followed by oxygen and then by nitrogen. So which of these molecule is most polar? So which will be most polar? Because HF is there, in which fluorine is most electronegative element, so that will cause a distortion to that will cause a uneven distribution of the shared pair of electrons shifted more towards fluorine. So fluorine will get a partial negative and hydrogen will get partial positive. That's why A is the right answer. Is it clear? Question 5. Next, question 6, which is a structure question. This question is about the structure and bonding of group 5 chlorides. So nitrogen trichloride is there, has a molecular structure. The displayed formula is shown. Complete the number of bond pair. So nitrogen belongs to group 5. So as it belongs to group 5, it will share 3 electrons. So when we show dot and cross diagram, this is how it will appear. So they're asking number of the bond pair around the nitrogen atom. So around the nitrogen atom, this is one bond pair, second bond pair, and the third bond pair. So there are 3 bond pairs around nitrogen. Number of lone pair around nitrogen, so there is only one lone pair. The bond angle for C and C. So to work out the bond angle, what we do, we check how many bond pairs are there and how many lone pair. So there are 3 bond pairs and there is one lone pair. So when 3 bond pairs are there and one lone pair, the bond angle will be 107, and the shape will be, it will be pyramidal, or you can also say trigonal pyramidal. So the bond angle will be 107 and the shape will be trigonal pyramidal. In question Structure question part B. Under standard condition, phosphorus 5-chloride PCl5 is solid made up of PCl4 ion and PCl6 ion. Antimony chloride 5-chloride is liquid made up of SbCl5. Explain why PCl5 has a higher melting temperature than SbCl5. So you can simply identify the type of forces. One is having electrostatic force, which is stronger in PCl5. Ionic bonds are there, so regular uh, or strong electrostatic force is there. Whereas SbCl5, a weak intermolecular force will be there, or London dispersion force will be there. So PaCl5 is having ionic bonds between PCl4 with a charge minus, sorry, plus, and PCl6 with a charge minus, and form a giant lattice, whereas SbCl5 is simple covalent structure formed by or and having weak force between the weak van der Waals force between the molecules. Is it clear? This question, that why PCl5 is solid at room temperature, whereas SbCl5 is liquid. Draw a dot and cross diagram to show a bonding in a molecule of SbCl5. Use dot to represent Sb electrons and cross to represent chlorine electrons. Show outer shell electrons only. So we just have to represent the electrons in the last shell. So Sb, as it is having 5 electrons in the outermost shell, and we have to represent the electrons of Sb with dot. So 1, 2, 3, 4, 5. And chlorine belongs to group 7. Each chlorine will share 1. So 1 chlorine, 2, 3, 4. And unshared electrons are there for chlorine. Belongs to group 7, so it will share 1, and unshared will be 3 pairs or 6 electrons. This is a dot and cross diagram for HbCl5. Then at low temperature, SbCl5 converted to Sb2Cl10, which contain dative bond. What is meant by a term dative bond? So how we define a dative bond? When both of the electron or a pair of electron, it involves a shared pair of electron coming from the same atom, shared between the two atoms, coming from the same atom, then we call that as a dative bond. Then complete a diagram to show a dative bond. So how there is a dative bond? When one of the like both of the electrons which are shared between the atoms are coming from the same. So as we know, chlorine is having a lone pair of electrons, like 3 lone pairs are there. So this chlorine will also have. So this chlorine actually, we draw the arrow from the one which shared both of its electron lone pair. So there will be two dative bonds, and that is between Sb and the lone pair of Cl. Is it clear? Arsenic also formed pentachloride with a formula of AsCl5. Give one possible reason why nitrogen is the only group 5 element that does not form pentachloride. So what is the reason why the nitrogen does not form pentachloride and rest others are forming? Because there is no, when we write the electronic configuration, for example, we write for nitrogen. So nitrogen is having 7 electrons. So when we arrange it is 1s2, 2s2, 2p, 3. But when we write, like this is electronic configuration for nitrogen, but when we write for phosphorus, which is 15, so it is 1s2, 2s2, 2p6, 3s2, 3p3. So we arrange 15 electrons, but still there is 3d, but that is empty. So phosphorus can arrange electrons in d orbital, but nitrogen does. There is no 2d orbital. We don't have any 2d orbital, so there is no 2d orbital for nitrogen, but there is d orbital available for other elements. That's why they can, for the same group, so they can adjust more electrons as compared to that of nitrogen. So the simple answer, there is no 2d orbital. So nitrogen cannot expand its octet. Like it cannot have more than 8. As you can see, the tin or Sb or arsenic, they can have 5, like adjusting 10 electrons in the outermost shell, but in case of nitrogen, maximum it can adjust 8 electrons in the outermost shell. In question 7, which of these ions has the smallest ionic radii? So again, to check the smallest ionic radii, what we do, we check by number of electrons. So we have aluminium. Aluminium belongs to group 3, and it is having 13 electrons. So 13 electrons are there, and 13 protons, but it lost 3. So it will be 13 protons are attracting 10 electrons. In case of gallium, that is 31 protons are there, and it will have 3 charges, so it will be 28 electrons. But because 28 electrons, it will be too large, so many electrons will be there, like so many electron shells are there, so it cannot be gallium. We need for smallest. Magnesium, it is 12 protons are attracting 10 electrons, and for fluorine there are 9 protons are attracting 10 electrons. So when we compare between magnesium, fluorine and aluminium, so aluminium is having greater number of proton than electron, so greater attraction to each electron, which reduces the size. So smallest size will be aluminium. A will be the right answer. Is it clear? In question 8, how many lone pair of electrons are there in outer shell of sulfur atom in the molecule of H2S or hydrogen sulfide? So in H2S, sulfur belongs to group 6, so it will share 2 electrons, and each hydrogen will share 1, so unshared will be 4. But they are asking how many lone pairs are there. 4 electron, and this is 1 pair, and this is the second pair. So there are 2 pairs, that's why C is the right answer. They're not asking total number of electrons, they're asking how many lone pairs of electrons. So you are checking the pairs, not the number of electron. 2 electrons will make a pair. In which sequence are the molecule in order of decreasing the bond angle? When we write BCl, because it BeCl2, it will be linear structure. When it is a linear structure, the bond angle is 180. About BCl5, boron trichloride, so this will be 120. And for CH4, the bond angle will be 109.5 tetrahedral structure. So decreasing the bond angle, the highest one will be BeCl2, followed by BCl3, then followed by CH4. So A should be the right answer. So we can identify the bond angle from the number of the bond pairs and lone pair. Which pair of ions will form the compound that is most covalent character? Most covalent character means which will cause a greater distortion to the negative ion. So as we know, the distortion or polarization depends on 3 factors. Number 1, size of positive ion. For a greater distortion should be small. Number 2, charge of the positive ion. For a greater distortion should be large or greater. And size of the positive ion or size of the negative ion should be larger. For a greater distortion, these are the things. So when we check the charge, all the positive ions have plus charge, plus 1 charge is there. So this factor is same for all because all of them have a plus charge. Then size of the positive ion should be small. These are group 1. So when we check the size, which will have the smallest size, as we go down the group, the size increases. So lithium is there, sodium is there, potassium is there, rubidium. So as we go down, the size will increase, the smallest size will be lithium. So this will give us the idea that lithium, and size of the negative ion should be big. So which is having a which negative ion is bigger? So when we go down the group for chlorine, fluorine, chlorine, bromine, and iodine, the size is increasing. So size of negative ion should be bigger. So iodine is there. So it shows that A is the right answer for this question. Is it clear? The polarization or distortion depends on the positive ion size. It should be smaller. Positive ion charge, it should be greater. And negative ion size, it should be larger. Moving on to the next question. Which diagram best represent the electron density in a molecule of hydrogen chloride? So when it is separate, it means ionic bond. But we know hydrogen chloride, it is formed by sharing of electron. So they should be overlapping. It cannot be A because A shows it is ionic. B, C, and D are showing ionic, showing covalent. But why this is not correct? Because it shows that electron density map equal distribution, equal chances there. That's wrong. Chlorine is having more electrons, so electron density in the side of chlorine will be higher as compared to that of hydrogen. This shows equal electron density, and this shows that hydrogen side smaller electron density and chlorine side it will be higher electron density where and chlorine is larger in size. So that's why D is the right answer. For question 12, which is a structure question, dot and cross diagram for ammonium ion. So how ammonium ion, so an ammonium ion is NH4 with a charge +1. Nitrogen belongs to group 5, so it will share 3, and hydrogen will share 1. Then there's a lone pair, and that lone pair nitrogen share with another proton, so the overall charge will be positive. Or there is a dative bond between one of the nitrogen and hydrogen. Explain the shape of ammonium ion using an electron pair repulsion theory. So what will be the shape of ammonium ion? As we know, the number of the bond pairs, the total when we work out the total number of the bond pair, so it appears that it is having 4 bond pairs. One, this dative is also counted as a bond pair 2, 3 and 4, and whenever 4 bond pairs are there, then it will be a tetrahedral. So it will be a tetrahedral because of 4 bond pairs. And what is the reason? Because equal repulsion of electron pairs are there, or 4 electron pairs arranged in a minimum repulsion or maximum separation. Which of these compounds has a greatest covalent character? So greatest covalent character, again, which will cause a greater distortion. So as we discussed, the size should be small, size of a positive ion should be small, and size of a negative ion should be greater. The charge all are group 2, so magnesium will be +2, +2, plus 2, plus 2. And when we compare the size, the charge on the positive ion is same. That is same for all the options. So this cannot be comparison. Then size of the positive ion should be small. So for a greater covalent character distortion, so which is smaller in size, magnesium, because we have beryllium, magnesium, calcium, barium. So as we go down, the size is increasing. So as the size increase, the distortion or polarization will decrease. Then the size of the negative ion should be larger for a greater distortion. So when we go down, fluorine, chlorine, bromine, so the size increases. So we have iodine as well. That's why B is the right answer. Is it clear? Question 13. In question 14, which of these forms of carbon does not contain delocalized electrons? So when we check the structure like fullerene, graphene, graphite, in case of diamond, because each carbon belongs to group 4 and it share all the 4 electrons, so there is no delocalized electron in case of diamond. That's why A is the right answer for this. Question 15, which of these molecule is polar? So when we work out the molecule, because oxygen belongs to group 6, so it will share 2 electrons and there are 2 lone pairs. So due to those lone pairs, there is a net dipole moment and that's why the molecule will be polar. But in BF3, it will be trigonal planar, so it will be symmetrical. And CF4, it will be tetrahedral. Bonds are polar, but the molecule is symmetrical, so it cannot be C. And PF, it will be trigonal bipyramidal. So there is a symmetry. That's why the bonds are polar, but the molecule overall is non-polar due to symmetry. But this does not have symmetry. Why? Because of 2 lone pairs. The bond pair, even the length is not same, and the bond angle is there of 104.5. Question 16. Which species has its correct shape and the bond angle shown? So when positive charge is there, it means carbon lost one of the electrons, so now it will share 3. The methyl radical, so 3 bond pairs are there and no lone pair, so it will be trigonal planar with a bond angle of 120. A will be the right answer. NH3, it's not pyramidal, it's pyramidal, but the angle is not correct because one lone pair and 2 bond pairs, so this bond angle is 107. That's why the bond angle is not correct. NH4, that is tetrahedral ammonium, as we just discussed, that in case of ammonium, 4 bond pairs are there. The dative is also considered as a bond pair. That's why the bond angle in a tetrahedral is 109. 0.5, so that's why even both are given wrong. In H2O, it's not a linear, it is a bent structure, as oxygen is having two bond pair and two lone pairs. The bond angle is 104. So geometry and shapes both are given wrong. Here shape is given correct, but the angle is given wrong. In this case, both are correct. That's why A is the right answer. Is it clear? Question 16. In question 17, cyclohexanol is a product of reaction 2. The bond angle of A is 109.5. Explain why the bond angle of B is smaller and include an expected value for a bond angle. So what is the reason? As you can clearly see, carbon does not have here, as the bond is there. This is a skeletal formula is given. So at this position, carbon is there. So it will have hydrogen and there's no lone pair. But in oxygen, there's a lone pair. That's why this bond angle, two bond pair and two lone pair. So this bond angle will be 104. So how we write the answer? Explain this answer. That the expected angle will be 104.5 or 104, you can say. Because carbon does not have any lone pair, where oxygen contain two bond pairs and two lone pairs. In question 18, going down from lithium to rubidium, the radius. So what happened for question 18? The radius decrease, that's wrong. The radius of ion decrease, that's also wrong. First ionization energy decreases. Why? Because when the size increase, like when you compare lithium, sodium, as the size is increasing, it will be easy to remove electron as it is far away from the nucleus. So C is the right answer for this. Polarizing effect increase? No, it decreases. Then question 19, a drop of nickel 2 sulfate, which is green, is placed in a moist filter paper and a 24-volt DC after 10 minutes. So it is nickel sulfate, so nickel plus 2 is there and sulfate ion. Sulfate, nitrate, carbonate does not move because of their size. So nickel ions, which are green transition elements, it will move towards a cathode. So what is the observation in this one? That a green color is moved towards the negative terminal and there is no other visible change. Why? Because the sulfate, nitrate, carbonate does not move because of their size. And the last one, the bonding in magnesium oxide is, so magnesium oxide, there is a magnesium ion and there is oxygen. So whenever ions are there, which type of bonding they have? They have ionic bonding. So A is the right answer for this question. So these are questions related to topic bonding, structures and shapes of the molecule. In the next session, we'll discuss more questions from this assignment. Any question related to the class today? So I'll end the session and share this recording.